All right, these are the answers to page 330 and 338. First, we're going to start with some derivatives. So when we take the derivative of a natural log, the natural log part is 1 over whatever's inside of this times the derivative of what was inside of it. So it's a chain rule. The outer function natural log derivative is 1 over, and then times that. Now, that is the derivative. If we want to simplify that, x can cancel 1x on the bottom, and we get 2 over x. For 46, same idea. The outer function natural log derivative would be 1 over whatever's inside times the derivative of what's inside. And that could be thrown on top or left like that, doesn't matter. For 47, the derivative now, the outer function is this fourth power. So we bring that down, drop it to a 3, leave the inside alone, times the derivative of the inside, which is 1 over x. For 48, when we do that derivative, we have to do a product rule. So we take the derivative of x, which is 1, times natural log x as is, plus x times the derivative of natural log of x, which is 1 over x. That's the derivative. Or if you want, x times 1 over x is just 1, so we could write it like that. 53 is a quotient rule. So when I do its derivative, it's going to be bottom t squared times derivative of the top, which is 1 over t, minus top times derivative of the bottom, which is 2t, over bottom squared. T squared squared would be t to the 4th. Now you're welcome to leave that, or we could obviously simplify here that t can cancel one of those. I'll bring this 2t in front. And if you wanted to go one step further, you could take a t out of the top and let it cancel one of these, so it'd be 1 minus 2 natural log t over t cubed. That'd be another idea. On 474, we're taking the derivative and trying to find a tangent, or find a tangent line at 1, 0. So this is going to be a product rule here. So that's going to be derivative of sine 2x, which is a chain rule. It's going to be cosine 2x times 2. Keep the natural log of x squared as is. Plus, now we're going to leave sine 2x alone, times the derivative of natural log of x squared, which would be 1 over x squared times 2x. So there's our product rule with some chain in both parts when we take the derivative. Now if we were to put 1 in for x, the derivative at 1 would be the cosine of 2 times natural log of 1 plus sine 2 times 1 times 2 times 1. And the natural log of 1 is 0, so that zeroes this whole thing out. And so we're going to end up with just 2 sine 2. And what's sine of 2? I don't know. Something. Whatever it is, that's the value. That's our slope. So our derivative, or our tangent line, would be y minus 0 equals slope times x minus 1. As weird as it might look, that'd be our tangent line. All right, and then 77 wants us to come up with the derivative implicitly. So the derivative of x squared is 2x. Derivative of 3 natural log of y would be 3 times the derivative of natural log of y. That's going to be 1 over y times dy dx. Derivative of y squared is 2y times dy dx. And derivative of 10 is 0. Now what I'm going to do is I'm going to swing this 2x over to here. I'm going to subtract it, and I'm going to pull a dy dx out. So I'm going to get dy dx times negative 3 over y, so negative 3 over y, plus 2y. So in that, I pulled this dy dx out of both of those terms, equals this minus 2x. Okay. And then the last thing is to divide by that. So dy dx is going to equal negative 2x divided by negative 3 over y plus 2y. That's the end of page 330. Then we go to 338, and we're integrating. And when we integrate these, it might be helpful to do a u sub, if that's something that works for you. The u would be, in this case, would be the whole bottom, this 3x plus 2. du would be 3 dx. So that means dx would be du over 3. So now I'm going to have the integral of 1 over u. I don't know why I'm writing a y there, sorry. 1 over u times dx, which is du over 3. So that 1/3 can come out front. Integral 1 over u du is going to be 1/3 natural log of the absolute value of u plus c. And then we do the re-subbing in. So put that 3x plus 2 back in. And there's our answer. Same thing on number 8. We might want to do a u sub there. The whole bottom should be the u. So 3 minus x cubed. Du would be negative 3x squared dx. So dx would be du over negative 3x squared. Okay. So now I come over here and I'm going to have the integral of x squared over u times dx, which is du over negative 3x squared. The x squareds cancel. That's what we want to see. We can pull this negative 1/3 out front now. Integral 1 over u du, which is going to give us negative 1/3 times the natural log of the absolute value of u plus c. And then the last thing we do is resubstitute for the u, 3 minus x cubed. And there's our answer. Okay. Same idea on number 11, just getting used to that u sub again. So u in this one is x cubed plus 3x squared plus 9x. That means du is going to be 3x squared plus 6x plus 9 times dx. So dx will be du over this, and I'm going to pull a 3 out. 2x plus 3. Because then when we come back over here, all right, we're going to have the x squared plus 2x plus 3 over now u times du over 3x squared plus 2x plus 3. And conveniently enough, that cancels. I can pull this 1/3 out front. 1 over u du gives us 1/3 times the natural log of the absolute value of u. And we'll just cut to the chase, put that 3x squared plus 9x back in, plus c. We've got a u sub here as well. The bottom is 1 plus sine t. So du would be cosine t dt. That means dt would be du over cosine. Okay, so if I come back over here, I've got the integral of cosine t over u times du over cosine t. So those cosine t's cancel. We're going to have the integral of 1 over u du, which will be the natural log of the absolute value of u, the natural log of the absolute value of 1 plus sine t plus c. On 43, if we multiply by dx, I'm going to get dy equals 1 over x plus 2 dx. If we integrate both of those now, we're going to get y equals the natural log of the absolute value of x plus 2 plus c. And I know that because if I took the derivative of this, it would be 1 over x plus 2 times the derivative of that, which is 1. So I would get this right here if I took the derivative of that. All right, now we're going to put 0 in for x, 1 in for y. I get 1 equals natural log 2 plus c. That means 1 minus the natural log of 2 is my c value. So our equation, y equals natural log of x plus 2 plus 1 minus natural log of 2. And you could maybe put the natural log minus natural log, make that natural log of x plus 2 over 2, but to be honest, this looks just fine, right? No need to get too crazy with it. All right, then we get 67. We're trying to find a definite integral here from area from 1 to 3 of this. If I pull that 4 out front, I've got this right here, okay? And that's going to give me 4 times the natural log of x from 1 to 3. It's technically the absolute value, but these are both positive, so that's not going to matter. So I go 4 times natural log 3 minus natural log 1. Top minus bottom. And the natural log of 1 is 0, so we're going to get 4 times natural log of 3. And if you wanted to, they could bring that up as an exponent, which would make this natural log of 81. Either one of those is fine. With 72, though, we're going to have to do a little bit of work here. We're going to have to split the x into both of those. So that's going to make x divided by x, which is 1, plus 4 divided by x, okay, dx. Now when I integrate, the integral of 1 is x, and the integral of 4 over x will be 4 natural log of x. We know that because that's exactly what we just did over here. We're doing that from 1 to 4. And so now if we put that top in, I'm going to get 4 plus 4 natural log 4 minus, put the 1 in, 1 plus 4 natural log of 1. All right, now, natural log 1 is 0. So this is going to 0 out. So it's really going to be 4 plus 4 natural log 4 minus 1, which will give us 3 plus 4 natural log 4. And again, if you wanted to, you could bring that up as an exponent, and it would be natural log of 256. Either one works. And that's the answer to those 2 pages.